Hi there. In this video, we'll be giving you a subject overview, i.e. what this subject's all about, how the assessment works, who's actually going to be teaching it, all of those sort of things. So start off, you get to meet me. My name's Robert. I'm an associate professor in the engineering department. I've got a background in computer science and electronic engineering, and then I did my PhD in field robotics. I'm also the head of the RAMPS robotics group. So it stands for robotics, automation, mechatronics, prototyping, and sensing. And so we do a whole lot of sensor and measurement things using robots in the field. I do a lot of work with civil engineers. So we put robots through sewers and measuring water tanks and things like that. But also do work with environmentalists and a whole range of different people. And later on in some of the case studies, you'll be seeing some of the different areas that we use measurement and instrumentation right across the department. My email address is up there, my phone number's up there. Really, if you want to get in touch with me, send me an email, ask for an appointment, and we can either meet in person or have a bit of a Zoom chat and discuss any queries, concerns, or doubtful points that you may have. Always happy to chat. And that brings us to our lab demonstrator. So Daryl is taking care of the labs. Daryl is redesigning all the labs from scratch. He's got a real strong background in electronics and measurement systems, and you'll see one of the systems that he's been involved in designing in some of the later case studies. His contact details are there, so if you've got specific queries related to lab things within the class, talk to Daryl. Here's your man. Anything else? Talk to me. Assessments, anything else, any queries about the actual content and things, I'm here to talk to about that. So that's the people that you'll be dealing with within this subject. Now let's get to the actual contents of the subject. Essentially, we start off by talking about some key measurement terms, the sort of things that we need to know and understand about things like resolution, for example, and precision. We then move on to looking at concepts of error and noise and calibrating our sensors because, well, our sensors often don't work out of the box. We actually need to do something to it so we don't just get rubbish information out of it. We then go through a whole lot of different types of sensors. So you see a bunch of different types there, and we'll go through looking at how we log data from those sensors and how we actually present that data to a user, because there's not much use getting a whole lot of sensor data and then doing nothing with it. Now you see the sort of sensors that we're dealing with. We're dealing with everything from like distance sensors, like LiDARs and things, through to force sensors that we might use on bridges and buildings, flow sensors where we're trying to measure hydraulic flow, pressure sensors, thermal sensors, subsurface sensors where we're trying to measure underneath something like ground penetrating radar or inductive sensors, and GPS sensors when we're doing mapping applications and things. Now, the actual teaching and delivery of this subject is in a few different parts. Firstly, we have our online lectures like this one. So you'll see my face superimposed over some lecture slides using fancy green screen magic, and you'll see this each and every week. We'll then have some online flip tutorials, and the basic idea is these are online tutorials. I'll be asking you a whole bunch of questions, putting them up on slides, multiple choice questions. You pick which one you think is right, and then you try and convince someone else of what you think is right. We then come back together, we talk about which one's right, we re-vote, and then if there's significant disparity, I'll go through the answer. Sometimes there's not, sometimes there is. We'll see how we go. We've got some really hands-on laboratories testing a whole bunch of different types of sensors. These are really key to actually understanding how these sensors work and some of the weird things that can happen with these sensors at times, and trying to choose the best sensor for the job, because ultimately that's what we want to do. We want to choose what's appropriate, what's cost effective, and what actually gives us the information that we need to make the decisions that we need to make. We have a mid-semester quiz, so halfway through a multiple choice quiz. We have our exam, and we have an assignment. Now, as part of the laboratories, part of the assessment for the laboratories, there's short lab quizzes, which basically test your understanding on what we've actually done through that laboratory class. And so Daryl will be explaining those in more detail in the actual lab classes. In terms of assessment, here it is, that mid-semester quiz is worth 10%. We have an individual assignment. We'll talk about that later on. That will be in the second half of the unit. We have our laboratories, which are worth 35%, and then our exam, right at the end, is worth 40%. In terms of the learning outcomes, you can see them here. And basically, we're trying to give you a wide perspective on sensors. Now, most engineers use sensors for something somewhere along the line. Maybe they don't even realize it. Lots of engineers might say, oh, the only thing I use is my phone. Well, a phone's full of sensors these days, from the accelerometers that are in there through to the high definition cameras that are in there to the video that they can capture on it, and lots of other things as well. Our GPS, for example. So we'll be covering a bunch of different sensors, understanding some of the principles, like how those sensors actually work, understanding how to use them, understanding some of the limitations, so what's wrong with them, how we calibrate them, how we use them in an industry sense, and how we apply them to engineering. Now, some of those will be things related to, for example, measurement systems around surveying and things like that. And so we'll be using GPS and going through details related to that. And that brings us to, well, how do we actually succeed in this subject? Well, this subject has both online components like the lecture and the tutorials and face-to-face components. And really the key way to succeed is by engaging with both of them. So before the laboratories, you should be watching the online videos. I'll provide the lecture notes in a form that has some blank spots in them for you to fill in details. Now, realistically, this is my little trick to keep you following along with the lectures and keeping YouTube and Facebook out of the picture, where you're filling in information, filling in the blanks in those lecture slides, and actually taking in some information as you do so. I've had students in the past complain if I forgot to put some blank spots in there, like I just didn't listen as well in that lecture because I wasn't filling in all those spots. So you'll be filling in all those spots. Make sure you attend and complete all the laboratories, because a significant amount of marks are associated with the laboratories, but also, and more importantly, a significant amount of learning is associated with those laboratories as well. So make sure you engage with all the material in all the different forms. Now, if you're having trouble of any kind, please talk to us early. Remember, if it's specific to the laboratories, have a chat to Daryl. If it's anything else within the subject, have a chat to me. Send me an email and we'll get it sorted out. Much easier to solve these problems before they snowball into something really large than afterwards, where it might not be recoverable. Pay attention to the LMS and the emails that come on LMS. All the details and things will be through there. And keep on top of things. With some of the online lectures and things, I know there's a temptation to let it slip behind a bit and I'll catch up one day. Don't catch up one day, do it now, do it before the labs so that it helps you understand what's going on in the labs because you've watched the lectures beforehand. Most of all, we want you to succeed. We want you to learn a lot about sensors to be able to apply them, because as professional engineers, we'll be using sensors probably at some point in our career. It's an important thing to know.